in the KMP, we have two types of protocols. The two protocols which we are listed here are Oakley and ISAKMP. So where ISA is Internet Security Association and KMP is Key Management Protocol. We have two types of protocols included for the key management here. While we are utilizing this key management or else in the modes, we have named security association a number of times. So we are going to see what is the security association also here, right? So let us start our session with in detail descriptions. See what is IPSec key management first of all. See, coming to the key management, everywhere we should be having this point in the symmetric or asymmetric type. And now in the IPSec also we are utilizing this because we have to know how we are communicating with each other with the key concepts. So there are two applications where we are utilizing n number of times in the IPSec. Those are AH and ESP. So for that purpose also we need key to be updated to the other end parties. So the key distribution is also important at the same time. So here we can do that key management in two types. One is a manual thing, the other is an automated one. Coming to the manual, we as a user, we can generate our own keys with few applications, whatever we have till now. And also we can communicate directly. This is possible for the static type of environments and very small type of environments. Now, automated thing is the where we are enabling as one of the user, immediately the security association will be entering into the scenario and it will be generating two keys. I mean, the pair of key will be applied two times because the sender will be having a pair of key and also the receiver will be having a pair of key, right? So this facilitation can be given by SA. So SA is responsible for the creation of keys on demand, right? So on demand indicates that automated system. So when a user enters, immediately SA will be acting immediately, right? So this is suitable for distributed systems and dynamic environments. There we have two types of protocols as we listed in the outline also. The first one is Oakley key determination and the second one is Internet Security Association key management protocols we have. So these two are under default automated type only. So in the manual version, we are going to generate, I mean, every user will be generating directly, right? So let us see what is Oakley. In the Oakley key distribution center, we are going to utilize Diffie-Hellman algorithm. So what is Diffie-Hellman algorithm is the algorithm which is going to apply with the exchange of the keys. So the exchange of the keys also will be done in two ways along with, I mean, as we know it already, in the symmetric key distribution, we have utilized Diffie-Hellman algorithm with R value, R1 and R2 values. And in the public key encryptions, Diffie-Hellman, we have exchanged the keys with the help of the public keys of the both sender and receiver. So that algorithm we are going to utilize in the Oakley version. So where it has a few features that are secret keys are created only when required. See, secret keys are created only when required to the both sender and receiver. And that exchange will be possible with a proper channel. That is, we have symmetric key exchange algorithms so that we need to have the agreement for that, right? So we also seen this symmetric key agreement and public key agreement in detail with the global parameters. Just go through that once if you want to go understand this again, right? Now, by using Oakley, we can eliminate man-in-the-middle attack because as we are utilizing Diffie-Hellman, so there is no chance of man-in-the-middle attack at all because there we will be understanding what is session key importance. So once the session key is into the scenario, that indicates that there is no man-in-the-middle attack. Thus, this is a part of Oakley algorithm. So the main features we are going to discuss here are it employs cookies. I mean, cookies are the things applied for the security purpose where we are going to block the channels which are not secure, block the websites which are not properly done. And nowadays we are getting this in the emails also where we are getting this is not a proper message, don't open this kind of messages, right? So there is a chance by using Oakley algorithm, there is a chance of clogging all the attacks which are not necessary, right? And along with this, we have another thing that as we are utilizing Diffie-Hellman key exchange algorithm, the parties will be strong enough to work with the session key. And it also generates one nonce where it can ignore replay attacks. So when there is a nonce utilized, the nonce will be created only once and utilized only once. So there is no chance of replay attacks, right? And at last, it can eliminate man-in-the-middle attack as we are utilizing Diffie-Hellman algorithm. So these are the few advantages and features of Oakley algorithm. Now let us move to the next algorithm, that is ISAKMP. See, coming to the ISAKMP, this is totally internet version of framework where it is responsible for the formattings also. Like whatever the format we are generating should be universal to all the protocols. So ISAKMP will utilize that format structure also along with few security attributes. So what is its header file will be saying is we can generate the message with one or more payloads. After generating, it should be followed up with the transport protocol. So the transport protocol will be the major key role here to send your data, I mean, to send your key to the other parties, right? So this is a very, very important one in the implementation of UDP protocols. So where UDP is totally connectionless, so we need this kind of ISAKMP header formats. So the header format is as follows. See, in the header format, we have initiator cookie. So where initiator cookie is responsible for who is the sender, who is the receiver, all this information will be saved, and at the same time SA, security association, will be activated here. Thus, the initiator cookie is initiated, the responder means both the sender and receivers are readily available to exchange their keys. Now, what is payload and major version? Payload is nothing but what may be the next upcoming packet we are about to receive. And we will be having the versions in two formats, major and minor. Here both are same. And exchange type. So what is the algorithm we are utilizing? Is that global parameter type of exchange or is directly with the KDC format of exchange? So what is the exchange type we have to give here? Now flag is to give information about is anything, I mean, is there any warning type of data, or else is it will be just of 8 bits, is it will be giving all the options. So what options it is giving means how we can exchange between, like is that the warning type or else is the exchange is done or no. So 0 or 1 options will be given by the flag. Now where message ID is nothing but we are going to give a unique ID to all the payloads which we are sending through ISAKMP. And the message length indicates exactly the message length. It may be of 32 bits. So what is the length of your message will be given here, right? Next is about SA. See, what is SA? So SA is nothing but security association. Coming to this SA, so everywhere we are utilizing this SA. SA is introduced in AH authentication header, even in ESP, and now in key management protocols. So thus we have to know what is this SA first of all. See, SA is nothing but security association. This is responsible for communicating all the devices securely. So what is the aim of this SA is? You have to, I mean, all the endpoints must get all the services securely. That is the first point. Now, second thing which we have to know about this is every time client wants to communicate with the server, it has to intimate to the security association. And at the same time, when server wants to communicate, server has to be associated with the SA first. So that indicates that both client and server must be in association with the SA. So what is this SAs are nothing but SA will be like if I am communicating from client to server, immediately that particular SA will be activated and this SA will be sent as a one-time communication, that is one-way communication. Now, when server want to communicate as a reverse, I mean the acknowledgement to the client, server must ongo SCA, then it must generate one SCA from server to client in the reverse order. Even though if we are saying reverse order, that is also one way. So thus we have to know that if we are communicating n number of times, we have to communicate to the SCA n times. So thus, as we are saying, so if it is the communication is two-way, if you're communicating 8 times, 4 SAs are enough. But here, as this is one way, if we are communicating 8 times, we need 8 SAs over there. So this is the first thing we should know. And what are the things which we are going to include in SCA? So SCA will say that what algorithm you have to utilize, either RSA or DDS or MD5. So all those information will be given by SCA, first thing. Second one, it is used to generate session key every time. And SAE is the main responsible thing in IP security where the communication is going to do in a secure way, right? So these are the things we should know about SA. And the installation of SA, I mean the configurations of SA is very simple in the firewalls on the routers. So there, every time when we are concentrating on the network layer security, immediately IPSec will be activated. So once IP security activated, immediately SCA will be enabled. So this is a hierarchy we should know first of all, right? And along with that, as we have just discussed, even AH and ESPs are utilizing this SCS, right? And along with this, we have to know that peer 1 to peer 2. So whatever it is, client or server, everywhere it is unidirectional. And there is one important component in this is a security parameter index. So this index is responsible for all the information saving about the security keys, attributes, and lifetime of the keys. Everything will be available in this IP SPI, that is security parameter index. Now there are few parameters which we are going to discuss now. So there are very less. The first one is sequence number count. So sequence number count is every time in the EAH and ESP we have utilized this. So where we are going to increment the value every time. The sequence counter overflow will say that your maximum value has been reached. Just to wait for some time and transmission of packets will be acknowledged by SCA. So anti-replay window and AH ESP informations are anti-replay window will be avoiding duplicate packets. See, when packet 1 is received and packet 2, 3, 4 are under traffic. And again, if I receive packet 1, so that is avoided duplicacy. So that can be done by anti-replay window in SCA. So along with this, we have AH and ESP information also. So where AH is responsible for authentication purpose and integrity purpose. So what are all the requirements needed will be saved over there, and ESP is responsible for encryptions also. Along with that, every time lifetime of SA is to be enabled. See, when an SA has been generated, its lifetime must be active always. If it is terminated, its life is gone. So again, we have to generate that SA. And along with this, we have to know about the protocol mode, IP security mode, where we have two types, tunnel and transport mode. So this SPI and a destination address and security protocols are few parameters where we are having endpoint addresses to be stored every time. So there we need a destination address, right? Protocol identifier will be associated with AH and ESP already. SPI just now we discussed. Now what is security policy, SP? See, policy is nothing but it defines type security applied to a packet. See, every time we are generating a packet and we are defining what is the network traffic of it in the IP layer. So for that, we have to protect every time. For that, we have defined a policy, and this policy will be interacted with two databases. So either your eligible packet or not eligible packet will be decided by the SP. If SP rejects, then that packet will be disabled and will not be sent to the other end party. Now, what are the databases we include are Security Association database and Security Policy database. Security Association database will be having all the parameters just now, whatever we discussed, and Security Policy database will be having either this packet is the originated one or as the fake one will be decided by this security policy. So all this information is about Security Association. If you have any doubts in this, please be free to contact anytime in the college or through comments. Thank you for listening.